When you picture the US Navy, you probably imagine vast blue oceans and mighty aircraft carriers, but a surprising amount of the Navy's future is being shaped far from any coastline, under the relentless sun of the Mojave Desert. At places like Naval Air Weapons Station China Lake, the Navy is pushing the boundaries of science and engineering, testing technologies too experimental or powerful for crowded coasts. The desert's isolation offers secrecy and security, letting scientists and engineers innovate without prying eyes. For decades, China Lake has been the birthplace of advanced naval weaponry, but today's work is about more than just better missiles. It's about reimagining the entire fleet. Here the Navy is developing disruptive technologies, directed energy weapons, hypersonic projectiles, and autonomous systems that could change the nature of conflict at sea. The Mojave's vast, empty spaces are perfect for testing weapons that sound like science fiction: lasers, railguns, and more. The desert is not just a backdrop, it's a strategic asset, enabling the Navy to experiment, fail, and innovate in secret. Modern warfare is no longer defined by geography alone. The Navy's future depends on dominance in cyberspace, the electromagnetic spectrum, and artificial intelligence. The lessons learned under the desert sun will shape the survivability and effectiveness of sailors and Marines on the high seas. The paradox of a Navy in the desert reveals a profound truth. The next era of naval power is being forged far from the water. The innovations born here will determine the balance of power for decades to come. At the heart of the Navy's desert experiments are revolutionary technologies: high-energy lasers, electromagnetic railguns, and autonomous robotic fleets. Lasers deliver concentrated beams of light, burning through drones or dazzling electronics at the speed of light, offering near-limitless shots as long as there's power. Railguns use magnetic fields to launch metal slugs at hypersonic speeds, obliterating targets without explosives and making ships safer. The desert's vastness allows safe testing of these powerful weapons and their integration into future warships. Most transformative, though, are unmanned and autonomous systems: drones, surface vessels, and undersea robots that can scout, surveil, and even fight, all coordinated by advanced AI. The Navy is perfecting these technologies in the desert, ensuring they work together as a resilient, networked force. When these innovations finally go to sea, they'll form a cohesive whole, ready for the challenges of a new era. The Navy's push for innovation is driven by a stark reality: the rapid rise of China's People's Liberation Army Navy. China now boasts the world's largest navy, with advanced missiles, submarines, and air defenses designed to keep U.S. forces at bay. This anti-access/area denial strategy threatens American naval supremacy and freedom of movement in critical regions like the South China Sea. Lasers, railguns, and unmanned systems are the Navy's answer: tools to penetrate defended zones and restore freedom of maneuver. The competition isn't just about ships, it's a digital arms race, with China investing heavily in cyber and electronic warfare to disrupt U.S. command and control. The Navy's focus on resilient, autonomous systems is a direct response, aiming to keep fighting even if networks are attacked. The future of Indo-Pacific security may hinge on the success of the technologies now being perfected in the American desert. New threats and technologies have sparked a fierce debate about the Navy's future fleet. For decades, the nuclear-powered aircraft carrier has been the centerpiece of American sea power, floating cities projecting unmatched force. But in an age of hypersonic missiles and advanced sensors, these titans are increasingly vulnerable. Some argue for a shift to distributed maritime operations, a network of smaller, cheaper, often unmanned vessels operating in coordinated swarms. Swarms can overwhelm defenses, create dilemmas for adversaries, and absorb losses without risking thousands of lives. The future fleet will likely blend both models, balancing the proven power of carriers with the resilience and adaptability of distributed forces. Proponents of carriers say new defenses can keep them relevant. Advocates for swarms argue that warfare's economics now favor many cheap platforms over a few expensive ones. This debate is shaping budgets, strategy, and the very experiments happening in the desert. The choices made today, between titans and swarms, will define the Navy's ability to control the seas for generations. The outcome will determine not just tactics, but the very nature of American naval power. The Navy's future hinges on finding the right balance. The Navy's vision for a distributed, semi-autonomous fleet depends on robust, secure networks connecting every sensor, shooter, and platform. This digital backbone enables unprecedented speed and coordination, but also creates new vulnerabilities. Every node is a potential target for cyber attack. Adversaries could hack, jam, or even hijack unmanned vessels. The Navy must invest as much in cybersecurity and electronic warfare as in lasers and missiles, rigorously testing defenses in desert simulations. Artificial intelligence adds complexity. AI can be manipulated or misled, so ensuring its reliability is a top priority. The Navy is building redundancy and decentralization into its networks, training sailors to fight through digital attacks. The invisible war for cyberspace and the electromagnetic spectrum will be constant, and victory will go to the fleet that best protects its digital heart. In tomorrow's battles, defending the network is as vital as defending the ship. Testing new tech in the desert is just the beginning. The real challenge is integrating it into the fleet. Lasers and AI that work on land must be adapted for the harsh, unpredictable conditions at sea. Ships need major upgrades to accommodate new systems, and digital integration with legacy combat networks is painstaking and complex. Sailors must be trained to trust and operate these technologies, shifting from direct control to supervising autonomous systems. Fleet experiments and real-world exercises are essential, revealing problems and refining tactics before new tools are deployed. The journey from desert prototype to combat-ready system is long, but it's crucial for turning innovation into real advantage. Only through rigorous integration can the Navy's investments pay off at sea. The Navy's technological edge is about more than military might. It underpins global security and economic prosperity. For decades, American sea power has kept trade routes open and deterred conflict, supporting the world's economy. A decline in U.S. naval supremacy could embolden rivals, threaten free navigation, and destabilize entire regions. The innovations pursued in the desert are central to preserving this order, deterring aggression and reassuring allies. A distributed, autonomous fleet isn't just about winning wars, it's about preventing them. The nation that best harnesses AI, autonomy, and networked warfare will shape the future of global security. The choices made now will chart the Navy's and the world's course for the 21st century. The quiet work in the desert is nothing less than an effort to secure peace and open seas for all.